B is also a formula that we've seen before. This is actually pi minus x is theta 2. So this is basically sine of theta 1 is equal to sine of theta 2. And we can show this again in the circle. We can see that the sine, if we take the angle x, the vertical position of the red angle x is same as the vertical position of the angle in blue, which is starting at pi minus x gets me to the blue dot. And those two vertical positions are equivalent, which is true. So this is a geometric proof of that identity. So this one here we can also just apply the formula. So I can apply my sine formula. It's going to be sine pi cos x minus, for the subtraction formula for sine is going to be minus sine x cos pi. Okay, and that's going to be equal to the right-hand side, which is sine x. And I can just simplify this. Sine of pi is 0. 0 times cosine x is going to be 0. So we get 0 here. Cosine of pi is -1, so I end up with sine x times -1. Well, minus negative sine x, it's going to end up being, I'm going to make that a plus sine x. And so what ends up happening is, on the right-hand side, we get sine x. On the left-hand side is sine x. So we've proven this identity using the difference identity for sine. And again, that proves the same thing as we did geometrically in the circle. But in this case, using a formula, and once we know this formula, this is actually much easier to do than showing it geometrically in the diagram.